adding integers. Today we're going to learn how to add integers by first starting with what we already know about adding. Addition is the operation that allows us to combine unequal sets or unequal groups. Addition is always combining two amounts, two or more amounts. And integers are nicely split into two groups, positives and negatives. Today you're going to see us using these two-sided circles, and when you see yellow it's going to represent positive and red is the color to represent negative. Positive integers, 3 plus 5, is very much what you've seen since elementary school. The reason we don't have to write positive signs is because this means the same thing as this. Positive 3 plus positive 5. Both of those would equal 8. Negative, remember we learned that a negative number must always have a negative sign. And this says negative 3 plus negative 8. Which means if I had 3 reds to represent negative 3, and I got 8 more reds to represent negative 8, I would have 11 reds, which would represent negative 11. Let's talk about this in real life. I owe my mom $14 and I owe my dad $4. Write the integer that represents the amount that I have. What is it that I have? Well, if you look here, he's saying, oh dear, because he has a debt. The amount that he has is negative $18 because he owes his parents 14 and 4. So negative 18 represents the integer that he has. Let's look at some problems here. This says negative 6 plus negative 8. Negative 6 would be represented with 6 reds plus 8 reds would equal 14 reds, which is negative 14. This represents owing someone $2 and owing someone else $3. Negative 2 plus negative 1 equals negative 3. Finally, some positives. 5 plus positive 7 plus 2. Well, we would add those positive numbers. 5 yellow plus 7 yellow plus 2 yellow would equal 14 yellow. Positive 14. 9 yellow and 1 yellow would make 10 yellow. Here's a negative 2 and a negative 4 and a negative 6. I could represent it with 2 reds and then 4 reds and then 6 reds, and I would end up with 12 reds, which is represented with negative 12. If you'll notice, this set of problems on this page require us to use the same signs. And so if the signs are the same, we simply added and we kept the sign. All of these were negative, our answer was negative. Negative, negative. A set of positives is positives. So, what do you do if the signs are different? What do you do if they are opposite? These are some real-life examples of a set of opposites that might be represented like this. I owe my dad $14. My friend paid me $14 for the video game I sold him. So if I owe my dad 14 and then I get 14, the integer represented by that is 0 because of course, I'm going to pay my dad. I rode the elevator down 3 floors and then back up 3 floors, which means that I ended up where I started, which would be 0 movement. I earned $10 babysitting and I bought a $10 concert ticket. That means that I spent the money I earned. That would be represented with 10 plus negative 10, which would be 0. So going back to look at these equations that we just solved, this was negative 14 plus 14, and it equaled 0. Down 3 floors, then up 3 floors, gets me to 0 floors moved. $10 plus negative $10 gets me $0. This is what a set of zeros look like. So this and this together make 0. And you can see that reminder here. Adding opposites makes a 0. All right. Adding integers if the signs are different. Each one of these we're going to represent with our circles. -4 plus 3. -4 would be 4 reds. And this means put on some more. So put on 3 positives. Now, we just learned that adding the opposites makes a 0. So we could decide how many zeros we can make. I've made my zeros and I'm left with 1 red. So -4 plus 3 leaves me with -1. Let's try the next one. Means that I could make 2 sets of 0 and be left with +3. 6 yellows and 1 red means that I am left with 5 yellows. So 6 plus -1 is 5. -3 plus 0. That means -3 plus 0. Oh, is this a 0? Why, sure it is. Do we need to place it there? No. -3 plus 0 is -3. Sometimes we get excited about learning something new, like this would be 0 and we would want to put it there. It's okay if you do, because this still represents -3. -2 plus -3. There are no zeros that I can make, so I'm left with -5, and this was -3. So, when the signs are different, or when they're the same, represent both of them using your tiles, make as many zeros as you can, and write what's left. Using a number line. We're going to solve these problems instead of using our tiles, using our number line. Sometimes it's important to learn how to do something more than one way. Because God made our brains differently, we learn differently. So maybe the tiles aren't your thing. Maybe a number line is your thing. And we learned that number lines, when we're adding, we travel in this direction. Because when you add a positive, you're going this way, you're getting a bigger answer. Well, when you add a negative, that's adding a debt. And so you're going to go in the opposite direction. So, on this number line, I would start at 4. And because it's a negative, I would go in this direction. So if I start at 4 and I travel 9, this could be 3, 2, 1, 0, 1, 2, 3, 4, 5. I started at 4 and I moved in this direction 1, 2, 3, 4, 5, 6, 7, 8, 9. And I ended at -5. Here I am adding a negative, so I am going in this direction, and I am starting at -3. So -3, moving 4 this direction, 1, 2, 3, 4. -3, -4, negative 5, negative 6, negative 7. I am adding a negative, so I am going in this direction. I'm going to start at 2 and move 5. 1, 2, 3, 4, 5. 2, 1, 0, negative 1, negative 2, negative 3. This one says start at negative 6 and move positive 1. So I'm going in this direction because I'm adding a positive. So if I start at negative 6 and I move 1, I am at negative 5. And finally, start at 7 and it's a positive, so move in this direction. Start at 7 and move 1, 2, which means that I am at 9. So, we've learned to use our manipulatives. We've learned to use a number line. Push pause and use either method. All right, let's talk about what you should have done. 3 negatives and 7 positives means that I could make 3 zeros and be left with positive 4. 4 plus negative 1 is 4 positives, 1 negative, make a 0, and be left with positive 3. 10 plus negative 4 is 10 positives, 4 negatives, which means that I can make 4 zeros and be left with positive 6. Negative 3 plus negative 3 is 3 negatives and 3 more negatives, which means that I would get negative 6. 9 positives plus 3 more positives yields positive 12. And finally, negative 6 plus negative 4 yields negative 10. Adding a set of opposites always equals 0.